Hi students, good morning. In our yesterday class, we are discussing topics belongs to in Unit 1, Chapter 2. So, in our last class, ending point is X-ray diffraction method. In X-ray diffraction method, there are entirely 4 different methods are there. One is Lay method, second one is Bragg's X-ray spectrometer, third one is rotating crystal method, fourth one is powder photograph method. These 4 methods are belongs to crystallography method. Crystallographic methods. What is crystallography? Each and everyone knows crystallography is the branch of science which can explain or which can completely give the information about physical and chemical properties of the complete nature or structure of crystals. That science can be called as crystallography. So, according to crystallography, you can give the complete information about the structure of the crystal. Each and everyone knows crystal is nothing but periodical array of lattice points. This combination of lattice point in which structure is existed in the crystal, that complete structure give the information according to your crystallographic method. So this crystallographic method is nothing but it is the science which can explain the complete structure. What is the structure of the given crystal? That structure can be determined by using the methods. Those crystallographic methods are these are 4. Entire Lay method, Bragg's condition, Bragg's X-ray spectrometer, rotating crystal method, powder photographic method. In out of 4, the first 3, especially the first 3, nothing but Lay method, Bragg's X-ray spectrometer, rotating crystal method. These 4, these particularly 3 gives the solid form of the crystal. You can give the structure of the crystal. The crystal must and should be in the solid, not in the liquid form, not in the powder form, not in the vapor form. Complete structure must be existed in the form of solid. The fourth method, nothing but powder photographic method. In this method, you can take the crystal particularly in powder form. Best example, each and everyone knows, everyone use the face powder in daily usage. The face powder which is in a very smooth manner. That smooth manner powder can be give the structure by using the powder photographic method. So these 4 methods are nothing but crystallographic methods to determine the structure of the given crystal. So entire 4 method, according to our syllabus, you have only 2. One is Lay method, another one is powder method. Nothing but you can give the crystal which is in the solid form. The solid form structure can be extracted by using the Lay method. That is the first one. Other than the solid, nothing but you can take the crystal which is in the powder form. That powder form crystal structure can be extracted from powder photograph method. So in our syllabus only 2 methods are there. Those are Lay method and powder method. So based on this you can clearly and in deeply explain those 2 methods. One is Lay, another one is powder method. So we are going to the first method, that is called as Lay method. Lay is the name of the scientist. So this method is determined or introduced by the scientist is Lay. So our first method is Lay's method. Entire 4 methods we are based on the diffraction condition. In every method you are using the diffraction condition. Already we have deduced diffraction condition. What is the diffraction condition? The diffraction condition is 2d sine theta is equal to lambda. This is the Based on this diffraction condition, we can determine the structure of the given crystal. The structure of the given crystal. So, the arrangement of Lay method is, so according to this diffraction method, you can use the rays are particularly X-rays. The X-rays wavelength is approximately equal to 1 angstrom. Why you are using X-rays in diffraction condition? The X-rays wavelength is 1 angstrom, which is nearly equal to the interplanar separation of the given crystals. Nothing but D value is approximately equal to 1 angstrom. That matching phenomenon is existed. You can give the structure very accurately. That matching phenomena, especially in your degree and intermediate point of view, we can use the matching phenomena, particularly resonance. The matching phenomena point of view, you can use the word is resonance. What is resonance? According to the waves point of view, the applied frequency value is matched with natural frequency. The applied frequency value is matched with natural frequency. That matching phenomena is called as resonance. That is the resonance phenomena. In LCR combination, particularly in alternating current, LCR series combination, the resonance frequency is N is equal to 1 by 2 pi into root LC. That is called as resonance frequency in LCR combination. Particularly at this resonance, the current value is maximum. So that matching phenomenon is occurred in crystal structures. The lambda and D values are more is always be equal. The given structure give the very accurate structure. On that phenomena, we can use the X-rays. Already we told the theory of X-rays also. So that is very important theory. So the Lay pattern. So according to Lay experiment, the main source of rays are X-rays. So for that X-rays, we can take X-ray tube. X-ray tube. Based on this, the X-rays are producing like this. Here, X-rays are produced. These are particularly X-rays. This can be taken as X-ray tube. So the X-rays are coming from the X-ray tube like this. So I am taking in this path, I am placing two slits. First slit, slit S1, slit S2. What is the main use of slits? These slits are used to passing the finite X-rays. Particularly, you can use only single X-ray. Only single X-ray is coming from this. So remaining X-rays are reflected back. So by using these slits, only single X-ray is coming from outside the slits. This X-ray is inciding on the what the structure is determined the crystal, that crystal is placed at that position. So I am taking the crystal. Maximum here you are using zinc sulfide, nothing but zinc blend. Zinc blend is used. So this X-ray is inciding on this. This crystal is nothing but combination of lattice planes, different lattice planes having, so like this, lattice points are periodical arrangement of lattice points. A plane is passing through the lattice points, that is called as lattice plane. So you can inciding the X-rays here, they can diffraction interference pattern is occurred. Diffraction interference pattern is occurred here. This condition 2D sin theta is equal to n lambda. This condition is obeyed. Nothing but Bragg's condition is existed. After Bragg's condition, these X-rays are diffracted in different directions like this. These different direction diffracted X-rays are collected on a photographic plate like this. Collected on a photographic plate. So each and on the photographic plate I am showing separately. I am taking a square photographic plate. This is the complete experimental arrangement of lay method. In this lay method, what are the main apparatus are used? One is main X-rays are required. That X-rays are produced by using the X-ray tube. After that, X-ray tube, from the X-ray tube different number of light rays are coming from outside. Only you need only single X-ray. For that purpose, you can using the two slits, slit S1 and S2. After these are number of X-rays are inciding on the slit S1, only single X-ray is coming out from the slit S1 and S2. The X-ray is inciding on the which structure is required of the crystal. That crystals must be placed at that point. So this X-ray is inciding on the crystal. After inciding, the X-rays are diffracted in all directions. Then all direction X-rays are collected on the photographic plate. Particularly this is called as photographic plate. Photographic plate. That is the complete arrangement, experimental arrangement of lay method. So this is the lay method. So on the photographic plate, the arrangement as shown like this. We are taking the square photographic plate, particularly at the center like this. This is the center. So the X-rays are inciding on the crystal. There is no diffraction is occurred. The central spot is existed without deviation or diffracted the rays. So at what the condition, this is wavelength is lambda, and the central fringe also wavelength is lambda. They have the high intensity. So there is no diffraction is takes place. The diffraction is not takes place. The entire X-rays is inciding on the central spot of the photographic plate. So at the central there existing the maximum. So here there existing the maximum intensity. Maximum intensity. So suppose on the crystal there existing the diffraction pattern. The diffraction pattern X-rays are collected on the photographic plate. The spots are existing on the circular spots. So these spots are collected. They are existing the circular spots. All fringes are combined like this. They can create the circular fringes around the central spot. The central spot is the undeviated X-ray having the more intensity. Remaining fringes are formed around the central spot. The spots are collected. They can create the circular fringes. This pattern can be called as lay pattern. That is called as lay pattern. Lay concentric circles fringes. This is based on these fringes. You can clearly explain the what the structure is existed. Based on at this condition they can they can obey the diffraction pattern. That is called as 2D sin theta is called N lambda. Suppose you can take the first order diffraction. N is equal to 1. You are inciding on the X-rays. Lambda is equal to approximately 1 angstrom. At what angle is existed? Otherwise, the distance between the interplanar distance is approximately equal to 1 angstrom, though they can calculate the glancing angle on the instant of the crystal. Once you can know the theta value, based on theta you can determine the structure of the crystal. So according to this experiment you can determine the glancing angle. Based on that glancing angle you can determine the structure of the crystal. That is called as experiment of Lay. So that is called as Lay experiment. That is Lay experiment. So that is called a geometrical arrangement of Lay pattern. Based on this experiment, clearly explain the structure of the crystal, growing of the crystal, and grain of the orientation. Grain of the orientation. So the main applications of this crystal, nothing but this Lay method is applications of Lay method or applications of Lay pattern is, first one is grain orientations, second one is lattice distortions, third one is precipitation phenomena. These three are the main applications of Lay experiment. What is grain orientation? What the, suppose you can take the crystal, at what angle is oriented, that orientation is explained on the Lay pattern. So theta can be calculated. So according to with horizontal and vertical, the crystal is placed at what angle is placed, that angle of glancing must be explained by using the grain orientation. So second one, lattice distortion. So here take the crystal. Crystal is nothing but combination of lattice points, combination of lattice planes. At any condition there is a defect. Suppose here there is no lattice point. So a defect can be identified by using the Lay method. And precipitation phenomena. This precipitation phenomena is occurred with respect to solution is occurs. Suppose you can take the crystal like this. In this crystal the complete structure is based on the atoms. In the crystal there existing some unwanted liquid is takes place. Some liquid is existed inside the crystal. So that liquid, at what condition is liquid existed? At this condition diffraction is dragged on. The diffraction, based on diffraction condition, at what the volume is occupied by the liquid can be explained by using the Lay experiment. That phenomena is called as precipitation phenomena. Precipitation phenomena. So based on Lay experiment you can clearly explain particularly applications of Lay method, grain orientations, lattice distortions, precipitation phenomena. This precipitation phenomena with respect to solution is takes place is at what the solution is takes place, at that condition precipitation phenomena is occurred. That precipitation phenomena can be explained by using the Lay pattern. Lay pattern. So that is the first experimental phenomena of crystallographic methods. So crystallographic method, first experiment or first method is completed, that is called as Lay method. So that Lay is nothing but scientists discovered the how the structure of the crystal can be designed. What is the structure of the crystal can be explained by using the method. That method is called as Lay method. In this Lay method you can take the crystal must and should be in the solid form. On the solid they can incidenting on the X-rays. After incidenting on the X-rays they X-rays, instanding on the X-rays on the lattice planes, Bragg's condition is occurred. So at the what the Bragg's condition is obeyed, the X-rays are diffracted in different direction. The diffracted X-rays are collected on the photographic plate. The photographic plate arrangement on the photographic plate, the X-rays are instanding on the spots or fringes. The collection of fringes which are in the form of concentric circles with central spot. The central spot is nothing but undeviated X-ray they have in the large intensity. Based on that concentric circles and distance between the circle, we can clearly explain the structure of the crystal. That is the first method to determine the crystal structure. That is called as Lay experiment. So first Lay method is completed. After completion of Lay method, second method is Bragg's X-ray spectrometer. In Bragg's X-ray spectrometer, here also you can determine the structure of the crystal. So what the structure of the crystal is determined, at that condition Bragg's condition must be applicable. Nothing but 2D sin theta is equal to n lambda. This condition must be applicable, no doubt. So in X-ray, Bragg's spectrometer consisting of mainly three parts. First part is X-ray tube. Second part is the turntable, rotating method. So, and third method is photographic plate, otherwise ionization chamber. At this condition, this is the experimental arrangement of Bragg's X-ray spectrometer. So in X-ray tube they can produce the, in all direction X-rays are producing. The wavelength of X-rays can be taken as approximately 1 angstrom. The 1 angstrom X-ray are incident on the crystal. On the crystal you can place the two slits in between the X-ray tube and turntable, rotating turntable, or crystal holder table. In between crystal holder table and X-ray tube, you are placing two slits. The main phenomenon of slit is to inciding on the X-rays on a particular crystal in a straight point of view. Nothing but monochromatic X-rays are inciding on the crystal. On that way, you can filter the remaining direction of X-rays. You can place the crystals, that is X1 and X2. And is X1 and X2. So the X-rays are passing through the slits S1 and S2. Only single X-ray beam is inciding on the crystal C. Particularly at this crystal, you can take the crystals are particularly nickel, calcite, etc. Nickel, calcite, so on. So on the crystal, the X-rays are inciding point, the X-ray is diffracted like this. The diffracted X-ray is collected in the photographic plate, otherwise ionization chamber. The ionization chamber consisting of high tension battery. The reflected X-rays are inciding on the photographic plate by passing through the slit S3. So at that condition, the glancing angle can be measured is theta. So for a particular angles, the particularly small angles, the arm rotating circular crystal is rotating. This arm can be rotated in 360 direction point of view at any condition. At what the X-rays are reflected, that reflected X-ray can be collected by using the ionization chamber, which is rotating on the rotating table point of view. So rotating table, this is the circular scale having the 360 degrees. So this is the angle of incidence, that is called as glancing angle. Once theta is known, at what the diffraction is occurs, what is the distance between the crystal, based on the interplanar distance, the structure of the crystal can be determined. The structure of the crystal can be determined based on the glancing angle. So at this experiment, you can determine the particularly glancing angle, that is called as glancing angle can be taken as theta. So this experiment is repeated in different point of view and different number of conditions. You can draw a graph. Between intensity versus incident angle. incident angle theta versus intensity, which can be represented by I also. So at this condition they can graph is like this. This is B1 A1, B2 A2, B3 A3. What are B1 B2 B3 A1 A2 A3? A1 A2 A3 and B1 B2 B3 are maximum values. The incident angle is increases, the intensity value is simultaneously decreases. What is the difference between A1, A2, A3 and B1, B2, B3? A1, A2, A3 are the maximum values, particularly those are maximum values. A1, A2, A3 are the maximum values with same wavelength of X-rays or incident. What is the B1, B2, B3? B1, B2, B3 are also the maximum values with different wavelengths. So here the X-rays are incident, the wavelength is lambda. This based on this lambda you can observe the readings in different conditions, theta 1, theta 2, theta 3, so on. On that condition you can occur the maximum values are A1, A2, A3. Otherwise, first observation can be taken as lambda 1, second observation can be taken as lambda 2, third observation can be taken as lambda 3. Different wavelengths you can occur the maximum values are B1, B2, B3. So depending on the wavelength, same length they occur the maximum values are A1, A2, A3, and different the wavelengths they occur the maximum values B1, B2, B3 are the values. So based on this condition, the Bragg's condition is 2D sin theta is equal to n lambda. D is the distance between the plane, 2D is constant. Lambda is also, suppose you can take the same, nothing but sin theta value is always proportional to n. Then the order can be ratio of order n1 is to n2 is to n3 can be taken as sin theta 1 is to sin theta 2 is to sin theta 3. Suppose the order can be taken as first, second, third order. Theta 1 is occurred first order. Theta 1 can be occurred first order. Theta 2 can be taken as second order. Theta 3 can be taken as third order. Then the ratio of their glancing angles are sin theta 1 is to sin theta 2 is to sin theta 3 is 1 is to 2 is to 3. Based on their orders with the same wavelength of X-rays are incident on the calcite or nickel crystal, their glancing angles are different with different orders. Then the ratio of their sine of the glancing angles must be equal to 1 is to 2 is to 3. Based on this experiment, you can determine the structure of the given crystal. So that is the Bragg's X-ray spectrometer. By using this, the main applications of Bragg's X-ray spectrometer are the main applications of this experiment. First one, to verify the Bragg's law. Bragg's law is nothing but 2D sin theta is equal to n lambda. 2D sin theta is equal to n lambda. So D is the distance between the planes. So you can take the crystal you can take the crystal, the D value must be constant. So D must be constant. Lambda is nothing but X-rays wavelength. It is also constant. Fine. So 2D constant and lambda constant. So sin theta value is always be proportional to M. So you can different the orders, the angles must be equal. So according to our relation with respect to different angles, sin theta 1 is to sin theta is to sin theta 3 must be equal to with respect to first, second, third order, which are in the ratio of 1 is to 2 is to 3. Otherwise, the number of observation you can take 2D sin theta must be constant. At every observation, 2D sin theta can be calculated must be equal to n lambda. So on that way, you can verify the Bragg's law. That is the first application of your Bragg's spectrometer. Second one, to determine X-ray wavelength. The incident X-ray wavelength lambda can be calculated. On that equation, 2D sin theta is equal to n lambda. The incident wavelength lambda can be taken as 2D sin theta by n. Based on this equation, you can determine the wavelength of given X-rays. And the third one, the application. Third application is to study the structure of the given crystal. To study the given structure. So what is the structure? Based on this equation, you can determine, first of all, you can determine the lattice constant A. Lattice constant A. Based on lattice constant, you can determine the D also. D is equal to, each and everyone knows, 1 by square root of h square by a square plus k square by b square plus l square by c square. First you can calculate the lattice constant. After calculation of A, you can determine the D value. Once D value can be calculated, 2D sin theta is equal to n lambda is verified or not. You can check it once. After that, once D is calculated, you can determine the number of lattice points per unit cell is calculated. Number of lattice points per unit cell is calculated. On the calculation is completed, you can find the value, get the 1, otherwise 2, otherwise 4. These values are kept. Once the number of lattice points per unit cell can be taken as 1, this structure is simple cubic structure. 2 is nothing but body centered cubic structure. 4 is nothing but face centered cubic structure. Based on number of lattice points per unit cell, you can clearly explain what the structure of the crystal is existed. So based on these two, nothing but Lay method and X-ray Bragg's spectrometer, you can determine the clear information about the structure of the crystal. Based on these two, you can clearly explain the structure of the crystal. Any drawbacks are existed according to the two methods. Yes. According to the Lay and X-ray Bragg's spectrometer, there existing the some failures are nothing but drawbacks. Drawbacks also existed. What are the drawbacks? Drawbacks. Particularly, what the experiment? Lay's experiment, nothing but Lay's method and X-ray Bragg's spectrometer. These two experiment point of view, there existing the drawbacks. First drawback is we can explain only single crystal. You can explain only single crystal. So multiple crystals are not explained by using these two methods. Nothing but Lay method and X-ray Bragg spectrometer method does not explain the large crystal. You can explain only single crystal. Nothing but you can take the crystal must be structured in small structure. You can take the structure is very small structure. And also third drawback is any fault is existed in the crystal, that fault not explained by this method. So according to the drawbacks of Lay and X-ray Bragg spectrometer, this spectrometer only explain the single crystal, not explained by multiple crystal structures. That is the first drawback. The structure must be in the small factor. The small structures can be explained by using the Lay method, and any distortion or drawback or faults are existing in the crystal, those faults cannot be explained by Lay method and X-ray Bragg spectrometer. These are the first two experiments to determine the crystal in crystallographic methods. So according to these two, some drawbacks are existing. So what the drawbacks are existing? These drawbacks are nullifying to create clear structure vision of the crystal by following the next method, that is called as rotating crystal method. Rotating crystal method gives the clear information about the solid crystals. Particularly the crystal must be in the solid form. The structure of the solid can be explained very accurately by following rotating crystal method. Suppose the crystal which is in the powder form, that powder form method can be explained the structure, or taking the crystal must be in the powder form. That is the next method. So next method is rotating crystal method. The next method is rotating crystal method. Up to this, two methods are completed. In our next class, you can clearly explain the next third method and fourth method. Third method is nothing but rotating crystal method. Fourth method is nothing but powder form of the crystal structure can be extracted, can be clearly explained the powder method. These two methods are explained in our next class. Okay.